Hello everyone, myself Gurbachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical system. Today, I am working as an assistant here at tutorial assistantship of the course Multivariate Calculus. Today, I would like to discuss some illustration with you on the behalf of week 1 lectures. So without any delay, let's start with the question number 1. First question is the equation of the level surface for the function fx yz equal to x minus y plus z divided by 2x plus y minus z passing through the point p 1 1 minus 1. To precisely find the equation of the level surface of fxyz given by this for the point on the point 1 1 minus 1. So this is the question related to the lecture 1 of week 1. So first of all, I would like to recall what is the definition of the level surface. So level surface definition, let me write formally what is the exact definition of this level surface. The collection, sorry, the collection of all points x, y, z in space where a function f intersect, or I can write function f with three independent variable has a constant value f x y z equal to some c is called level surface of f. So now the question arises how we can find the value of this c. For that, since we know that from the question it passes through the point 1 1 and minus 1, so we will put the value 1 1 and minus 1. It come out to be 1 minus 1 divided by 2 plus 1 plus 1. So it will come out to be minus 1 by 4. Now we want to find out the level surface equation, and from this above definition it will be fxyz equal to c. So what is fxyz? X minus y plus z divided by 2x plus y minus z. So we will put it here, x minus y plus z divided by 2x plus y minus z equal to minus 1 by 4. It will come out to be 4x minus 4y plus 4z, which will be equal to minus 2x minus y plus z. 6x minus 3y plus 3z equal to 0. It will be the required level surface of the function f. I hope everybody is clear with this solution. Okay, now let me move to the second question. let fxy is equal to 3xy divided by x square plus y square, where xy not equal to 0 0 and 0 when xy equal to 0 0. Then limit xy 0 0 fxy will exist or not. We need to tell this. So in the lecture, we have learned how to calculate or show the existence of this limit. So let me recall first. For the existence of limit, we need to apply the epsilon delta definition, which is as follows. Limit, suppose I am talking about any arbitrary AB, suppose this is equal to L, then we formally say that for any given epsilon greater than 0, there exists a corresponding real number delta greater than 0 such that for all xy in the domain mod of fxy and L is less than epsilon whenever 0 is less than the distance between these 2 points, that is x minus a square plus y minus b square. This quantity is less than delta, or on the behalf of this quantity we may also write that 0 less than mod x less than delta, comma 0 less than mod y less than delta. So this is the method to show the value of the existence of the limit if we know that limit exists. But what
Mod
if,
x minus c.
what's that?
Modulus of x minus c.
What will be? Can you repeat it?
The last line 0 less than mod x
Oh,
minus c.
sorry.
Yes, sir, it will be x minus a
Yeah,
y minus b.
understood. It should be x minus a and 0 less than y minus less than delta. Thank you. So to show the existence of the limit, we need to follow this path. While if we do, we can show that from a different path, two different paths, the limit is different. Then we can say that the limit does not exist. Here we will apply first of all the different pathway so that to show the non-existence of the limit. Suppose we go from along y equal to 0 curve, that is x-axis. So for y equal to 0 curve, limit xy tending to 0 0 fxy, it will come out to be, since y is equal to 0, the limit remains x tends to 0 and the function was 3x into y and y is 0 divided by x square plus 0 square. So it will come out to be 0. While if you choose some another path, say along y equal to x. So for y equal to x, this limit xy tending to 0 0 fxy, this will come out to be limit x tending to 0. Here x tending to 0 is only because we are taking y equal to x. So when x tends to 0, then y also tends to 0. So we are just writing here x tends to 0. So 3x into x divided by x square plus x square. So it will come out to be 3 by 2. Now clearly one can observe that here it is coming out to be 0 limit, and while here it is come out to be 3 by 2. So that means here are two different paths and we are getting different limits. So the limit of fxy at 0 0 does not exist. Limit xy tending to 0 0 fxy does not exist. There is one another method. Here I have taken two different curves. So we can in general also take, suppose we consider y equal to mx, where m is any real number. So what will happen along this limit xy tending to 0 0, this fxy, this will come out to be limit x tending to 0, 3x into mx divided by x square plus mx whole square, which will be limit x tending to 0, it will come out to be 3m x square divided by x square into 1 plus m square. So it will come out to be 3m by 1 plus m square. So it is dependent on m. That means that when we change the value of m, that we are changing the curves. So along with the changing of curves, the value of the limit is changing. Again, the conclusion is the same, that limit of this function at 0 0 will not exist. There is one another method that I would like to emphasize
Excuse
here.
me.
What?
The path should be chosen such a way that the
Okay.
path passes through the origin.
Yes. So next one is we can change into polar coordinate also, r sine theta. So after in polar coordinates, this fxy, that is limit, it will convert to limit r tends to 0, r cos theta, r sine theta, limit r tending to 0, 3 r cos theta, r sine theta divided by r sine theta whole square. So it will come out to be 3 cos theta sine theta divided by, in the division there is nothing, so it is depending on theta. So again we can say that the limit does not exist. So till now we have learned like how to find out level surface, and the second thing is that how to show that non-existence of a limit. The next question is examine open and closed sets. Suppose S1 we have given xy from r square such that x plus 4y is strictly less than 3. So here we need to examine whether this set is open or closed or neither. So for that, first of all, we have to draw this region. So for simplicity, we change this line equation into the slope intercept form. So it will come out to be x by 3, y divided by 3 by 4 equal to 1. This is the equation of line. So we will draw it. So it will come out to be 3 comma 0 and 0 comma 3 by 4. So we will draw it like this. Now we need to judge which region is less than x plus 4y is less than 3 corresponding to, or above 1 or the low one. So for that, we just put the origin into the equation. So if we will put x plus 4y at 0, 0, so it will be 0 plus 0, which is equal to 0, which is less than 3. That means the lower region of the line corresponds to the region S1. And moreover to that, since here is the less than strictly inequality, so this line will also not include. So for that, we what we will do, we will simply make it dotted. So we make it dotted, so to show that this line is not included, and the region will be this one, this whole lower region. Now we are ready. What is S1? Now we have to judge what is open and closed set. So let me write formally what is open set, or you can say open region. What is open region? So let me formally write it. What is open region? So to write open region, a region A is, or you can say for to avoid confusion, S is open if it it contains all of its interior point. And without writing, let me recall what is an interior point. A point x naught y naught of S is said to be a, pictorially let me recall, suppose this is some set S. So a point x naught y naught, suppose this is x naught y naught. This is said to be an interior point if we get a delta greater than 0 for which the disk will lie in uh, will lie in S. So we say that that point is an interior point. So for S to be open, all the interior points should be in S. The next definition is closed one. What is a closed region? A region S is closed if it contains all of its boundary points. So in this figure, let me draw what can be a boundary point. Suppose this is some point and we have drawn a disk, or you can say, so boundary point means every disk drawn on this x naught y naught, every disk drawn in the x naught y naught has a non-empty intersection with S as well as this S complement. So you can see that here this is the intersection with S, while the lower region is intersection with S complement. So we can say that this is a boundary point. Now we need to check in this S1 whether it is containing its boundary or it is a open set. So clearly the boundary of this S1 region will be this line, this line. So it does not contain its boundary. That means S1 can S1 is not a closed set. While if we will see whether it is open, it is an open set or not. For that, we need to take some random point. You can take any random point. If you will draw a disk of delta over this, then clearly one can observe that this disk whole pure entirely contained in this S1. So S1 is an open set. So what's the conclusion? Conclusion is that S1 is an open set. Now let me define some one another set B, that is S2, which is the collection of all those tuples of R square such that x square plus y square is less than 9. So I will prefer you just try for 5 minutes. Then let me know whether it is an open set or a closed set. Then I will let you know what's the correct answer. Please try.
So it will not be an open set.
Not open set. Why?
So same reason as the previous one, as the
The previous
perimeter.
one is an open set.
Sir, it is an open set.
Yeah, it is an open set. You might get confused. The previous one is an open set. It is a not a closed set.
Sorry, sir. Sorry, sir. Sorry, sir.
Yeah.
Sorry, sir. I just got a bit confused.
Yeah.
Yeah, yeah.
So could you let me the proper reasoning for this?
So if we draw this region, it will be a circle entered at origin,
This
which has radius of 3.
Okay.
Due to the strict inequality case here,
Yes.
we can't consider the perimeter of this circle in the region. So whatever point we choose inside the region will only have intersection with the region only, and
Yes.
no an intersection with its complemented with the
Okay.
complement of the region. So that's why
Okay.
this will not be closed and it will be an open set, sir.
Okay. Good. Thank you. So let me explain here. This is the equation of a circle. If you will rewrite it as clearly, this is a circle in R square centered at the origin and with radius 3. So let me draw it. So this will be a circle. Okay. Just assume it at circle. So here it is 3 comma 0. Now, since there is a strict inequality, so we cannot include its circumference, or you can say boundary. And since it's less than, so it will be the inner region. Why it will be the inner region? Again, put 0 0 in the left hand side. So it will be come out to be 0 and 0 is less than 9. So it will be the inner region. Now the point arises, it is a closed or an open set. So clearly it is not a closed because there, if you will take this point, you cannot take this point. This is the boundary of this circle. So since you cannot take this point, therefore it is not a closed set. While if we talk about the openness, we will take any point in this and we will draw a disk around it and it contains entirely in this region S2. Therefore, it is an open set. Now let me give you one another set S3, which is collection of all those points R squared such that 3x plus 2y greater than 9. Now please try this. It is whether it is an open set or a closed set.
So it will also be open.
Open. Okay. Reason?
So reason is if we plot this region,
Yes.
then dividing both side with 9, we get x by 3 plus y
Okay.
by 2 by 9 greater
Wait,
than
wait,
1,
wait. X by
and
3
same the reason
plus
of
y
first one.
9 by 2. equal to 1. This will be the line. Okay.
Sir, yes, sir.
So I will draw a line. This will be some 0 comma 9 by 2 and this will be some 3 comma 0. So I need to draw a line here crossing these 2 points. Okay. Now because of the strict inequality we will make it dotted. Now tell me what will be the which region is going to be in the set S3? Which region? The above one, the lower one?
It does not contain origin.
Okay. Since it does not contain origin, I hope everybody is understanding that. So this will be the set S3. Okay. Now complete your reasoning.
Sir, so if we look at the region,
Hmm.
so here also the boundary is not included. So if we
And what
take
is the
any,
boundary? Boundary
the
is this
boundary is that
line.
line,
Line
that
itself.
line x by 3 plus y by 9 by 2 is equal to 1.
Yes.
There is a line.
Absolutely correct.
So this boundary is not included in the region. So if we take
Yes.
any point in this region and we
Yes.
draw a disk, so
Yes.
it will not have an intersection with the complement of this region. So with that
Hmm.
logic, we can say that it is not closed, hence it is open.
Good. Now I'm giving you just last example to get better understanding. Just let me know what is the region and the answer. This time we will not discuss what is the reasoning behind it. X square, in fact, let me rewrite it. X minus 2 square, y minus 3 square greater than equal to some 25. Now you just let me know what would be the figure of this.
Can we say if it is not closed, it is open?
Yes, we can say that.
So there are
But
sets both are
except
closed.
except there is one set, non-trivial set, which is open as well as closed. Otherwise, we can say that if a set is open, then that means it will not close. Non-trivial set specifically, if I would say.
So this region, I guess, it will be forming a center having origin 2 comma 3 and having radius 5.
Origin or center?
Sorry, center.
Yeah.
Sorry. It
Okay.
will have the center at 2 comma 3 and radius with 5 units.
Yes.
And as there is no strict inequality, so we can include the boundary case here.
Okay.
So
Let
with
me draw
that,
it. This will be suppose 2 comma 3 and there is a circle. Since this distance is 2, although it's go far away, I am just drawing here a rough figure. Let me mention it again. So this is 2 comma 3. This distance is 2 and this distance is 3. So it will go somewhat till here and here somewhat till here. So the circle will be made like this. I'm just drawing roughly because its radius is 5. I
yes, sir.
hope everybody is getting it. This is the radius. Now tell me which would be the S4, the inner one or the outer one?
Outer one, sir.
Good. The outer one being the S4. So it is open or closed?
So it will be closed because here the boundary has been included. So if we
Good.
take the boundary point
Good,
in the
good, good.
region of the disk, then
Okay.
it will both have its
I
intersection.
hope this question has made a clear concept of what is an open or what is a closed set. Okay?
Sir,
Yes, please.
sir, can you please show this set as one?
Okay. Yes. Yes, this is S1.
Sir, actual set S1.
Okay. This one is S1 set.
Yes, sir. Okay, sir. Thank you.
Now let us move to the next question. We have learned the epsilon delta definition formally, like when the limit exists, what will be the epsilon and what corresponding we have to find out a delta. Here, in I'm giving you that question in which corresponding to epsilon, you have to find out the corresponding delta. So let fxy equal to x square y plus 4x y square divided by x square plus y square whenever xy is not equal to 0, 0 and 0 whenever xy equal to 0, 0. Okay. Now find out condition on delta for which fxy minus f00 is strictly less than zero point 0.1 whenever this is x square less than delta. Okay. So in the second question, we have mentioned the epsilon delta definition with respect to a limit. Here, what is the change? They are kind of emphasizing that our function f is continuous. Since we are finding out this difference, so f is continuous and the corresponding to this epsilon equal to zero point 0.1, we have to find out its corresponding delta. So for that, let me first write the formal definition of it. Let xy tending to suppose some x naught, y naught, fxy. We know that the function is continuous at x naught comma y naught. Then what would be the definition? For each epsilon greater than 0, there exists a corresponding delta greater than 0 such that sorry fxy minus fx naught y naught is less than epsilon whenever 0 is less than under root x minus x naught square plus y minus y naught square less than delta. So this is the definition which can be reduced to the line for this question minus f00 less than epsilon whenever this is less than delta. And here epsilon is equal to zero point 0.1. So I hope you got the picture that this function is, they are saying indirectly this function is continuous at 0, 0. Now you need to find out what is the value of delta for this. So for that, we will consider fxy minus f00. Consider this function. So what is the value of fxy whenever it is not 0? X square y plus 4xy square divided by x square plus y square. X square y plus 4xy square divided by x square plus y square. Okay. And what is the value of f00? It is exactly 0. So it will come out to be 0. Now write it as x square y plus 4x y square. Okay. The next step is we can apply the triangle inequality, that mod of a plus b is less than equal to mod of a plus mod of b for
Less
all
than one.
what
The the condition on delta should be less than 1 by 50.
1 by 50.
Yes.
um yes, I no, I guess not so. Let me see. Zero point 0.1 divided by 2, it can be. Let's see what could be the answer. I think it will not 1 by 50, it is something else. Let's see. So it will come out to be x square mod y divided by, since x square is positive and the x square plus y square is positive, so I am not writing mod on it. Next one is 4 mod x y square divided by x square plus y square. Now we know that, can we say that x square is less than equal to x square plus y square? Anybody has any argument regarding this inequality?
So since y square is positive and x square is positive, so
Absolutely correct. So we can write it. Any positive quantity, we are adding a positive quantity, so it will be less than equal to. So we can see it as x square plus y square is less than equal to 1. So with the help of this argument, we can write it here mod y. In the similar way, for y square, we can write it as mod x. Okay. So we can rewrite it as you can into 1 into 1 for more clarity. So it can be rewritten as mod y can be written as this and mod x is can be written as. I hope everybody is clear with that this step. So next, can we write it as again with the similar argument? Can we add this plus x square? Since it is a positive quantity, so the inequality will be less than equal to. Okay. And here you might observe one more thing is that here I have talking about equality, inequality. Here I am talking about equality. So it's just showing the relation of this line with the previous line. From the previous line, we have just have done some manipulation. That's why we have written here equality. While here we are adding something, so it will be the inequality. So from here, we can get it equal to 5 under root x square plus y square. Okay. Now from the above definition, we know that this quantity is less than delta. So it will be come out to be less than 5 times delta. Okay. Now what we need? We need this should be less than zero point 0.1. That 5 delta should be less than zero point 0.1. So for that 5 delta should be less than zero point 0.1 and delta should be less than zero point 0.1 by 5, which can also be written as 1 by 50 or 0.02. I hope someone says 1 by 50, I guess.
Yes, sir, I told.
Okay, good. So your answer is correct. I hope everybody is clear that how we have find out a delta corresponding to the epsilon value of zero point 0.1. If yes, then I can move to the next question.
sir,
Yes, please.
sir, can we take this inequality as mod x square plus mod y square? The last
This in
inequality.
this
Yes,
inequality,
yes, sir.
what you want to take?
Mod x
This one.
no, no, sir. Mod x square plus mod y square. Basically, x square plus y square.
This will be mod x square or plus mod y square. Like
Yes, sir.
that? Why you want to take it?
Sir, from starting, I have changed the inequality.
Okay. How? Could you please let me know?
Sir, the first inequality, you see x square mod y upon x square plus y square, this one.
Yes, yes.
Uh,
You're
if
talking about this
I,
line.
sir, if I replace this by x square upon x square plus y square plus 4 upon x square plus y square.
Hmm.
Sorry, 4y square upon x square plus y square.
Okay.
Can I do this?
Mod x is less than x square plus y square. You are talking about that, right?
No.
You are replacing this. Let me write it here. You are replacing mod x with mod x square plus mod y square. Is that so? Or something else?
Hello?
Yes.
Sir, from triangle inequality, sir. Sir, start from triangle inequality, sir.
Here, this step, na?
Yes, sir. From this,
The
I
above
want
one?
to, sir,
Hmm.
I want to write it as x square upon x square plus y square plus
Hmm.
4 times y square upon x square plus y square.
Okay.
This should be less than, sir. This should be less than x square upon x square plus y square plus 4y square upon x square plus y square.
I'm sorry, I'm not getting you exactly. Can you tell me directly the what would be the inequality after this step? Tell me that
Sir,
exactly. What is the line
sir, after triangle inequality, sir.
after triangle inequality? Okay, after this
Yes.
step. Okay.
Yes, sir. X
Tell me.
square upon x square plus y square
Okay.
plus 4 times y square upon x square plus y square.
Okay.
Yes, sir. Can we
Uh, where
write this?
where this is mod y and mod x?
Yes, sir.
Where this is mod y and mod x? I'm asking. Why you can write this? I mean, you are
The
just
mod
skip.
y should be positive, sir. Mod x should be positive.
No, we cannot write it. If you will do that, suppose I am saying that otherwise it is not possible. If you are doing that, suppose, then this will be less than 1 plus 1, this will be 2. And how can you replace this mod y? Since it is a positive quantity, that is true. But you cannot replace it. Na? And we need to get to this place where we have to find
Sir,
out this
mod
value.
y can be less than 1.
Mod y can be less than 1. How can you
Yes,
say
sir.
that? How can you say that? Mod y can be less than 1.
If mod y is greater than 1 and sir, mod x is greater than 1, then we can write this inequality, sir.
So,
But
see,
in case if
see,
mod y is less than 1, then it can be fail.
listen. So you cannot generalize it now. Here
Okay.
we have given that xy can be anything except 0, 0.
Yes, sir.
So that inequality that you are talking about is not possible. And the
Sir,
other thing is
sir, it
that
will fail when, sir, mod y is less than 1.
exactly,
Yes,
exactly.
sir. Okay, okay, sir. Thank you.
And
Sir,
okay,
got it.
okay. Let me just erase these extra steps. So let me move to the next question. In this question, we have we will discuss about the double limit and the iterated limits. Can we set up any relation in the double limit and the iterated limits? We will see that. So fifth question is let fxy equal to y cos 1 by x whenever xy not equal to 0 0 and 0 xy equal to 0 0. Now tell me whether limit xy tending to 0 0 fxy, or you can say examine the existence of limit x tending to 0. This is the double limit and this is the iterated limits, you can say, and limit y tending to 0, limit x tending to 0 fxy. So examine the existence of these three limits. First of all, in the class, we have done such examples. So first of all, you will try by at your own, then I will let you know what is the answer. Please try first.
So the first and second one will exist, but the third one will not exist.
Okay, your answer is correct. I will ask after some time. Let others also try.
Sir, first and second are 0.
First and second are 0. Okay.
Third one, sir, does not exist.
Okay. Your answer is correct. So let us compute it. Suppose for the double limit, what we have to consider fxy minus 0. Can I do that? Fxy minus 0. Can I start with this step?
Yes, sir.
Why? Why? Why I have taken fxy minus 0 rather than minus 1 or something minus 2?
Sir, because at 0, 0, the function value is 0.
Okay. So you want to say the limit exists and that is 0. So before doing this step, I have to must show that limit is 0. Then I can only proceed by showing the steps. So for that, we will first consider xy tending to 0, 0 of fxy as limit xy tending to 0, 0 y cos 1 by x. Okay. Now here y is tending to 0 and observe here it will come out to be some any finite value between minus 1 to 1. Can anybody let me know why I am saying that?
So range of cos function is between minus 1 to 1.
Correct, correct, correct. So it is anywhere finite value between minus 1 and 1. And the multiplication part is tending to 0. Since it is tends to 0, so it will come out to be 0 because 0 into any finite value will be 0. So now we can consider or we can show the existence of a limit fxy minus 0. So it will be y cos 1 by x minus 0. It will be can be written as cos 1 by x, which can be written as mod y into 1. Why? Because mod of cos theta is less than equal to 1 for all theta.
So when you have proved the limit is 0, what is
Yes.
the need to go for the epsilon delta definition?
Here I have just given a way that its limit is 0. Now to show the
That,
existence, we have to follow the yes,
that is the end of the problem. The limit exists and the
yes.
value is 0.
You have
But
to
for
show
the
it by
more clarity, we have to show that by epsilon delta definition also, no? That's why I'm doing that. So let me proceed. Under root y square. So this can be less than equal to x square plus y square. And we know that this x square and y square is less than delta. So we can choose delta is equal to epsilon, which will give us that mod of fxy minus 0 is less than epsilon whenever 0 is less than x square plus y square is less than delta, where delta is equal to epsilon. Okay, so this is the existence of the double limit. Now let us talk
Sir,
about yes,
sir, the last step is necessary, sir,
which
to
step?
write less than or equal to under root x square plus y square. Can we
Um,
not directly say from here that
yeah, we can
whatever
say
x we
there.
can choose?
Let me mention here. Let me mention here. I have mentioned two definition of epsilon delta. So let me mention here. Here is the epsilon delta definition. We can also follow up this second inequality. Here, this one. You can follow up this also. Mod y is less than delta. Since the point is here 0, 0. So it will give out to be 0 less than mod y less than delta. Directly we can also do. Okay. Or we can also go with this step also. I hope that is clear now.
Yes, sir.
Okay. So now let us talk about the iterated limits. So for the iterative limits, we first consider limit x tending to 0. And I would like to mention here one point that one of the students has mentioned, that here itself I have shown the existence of limit. That is true, but for a better understanding, I have shown this step. You can also end up the problem here, the existence of a double limit. Okay. Now for single limit,
Sir,
yes.
sir, what should be the first step for examining the limits of function of
First step is to examine the limits. Is this only this step? This is the first step.
sir?
When
Sir,
it
yes,
yes,
yes, sir.
then it is told you to that show that from the silent data definition, then we can follow this step. I have followed this step just to create your better understanding and a friendly nature with this epsilon data definition. Okay.
Yes, sir.
Okay. So fx y, this will come out to be limit x tending to 0, limit y tending to 0, y cos 1 by x. Since this function is independent of y, it can come out cos 1 by x, and the rest part will be limit y tending to 0 y. So limit x tending to 0 cos 1 by x into 0 will be 0. I hope everybody is understand why I replace this with 0. Can anybody
Because
give me a valid argument?
this
Yes.
is a zero function, sir. Actually, yes.
No, I'm putting in y. So there is a better argument, please.
0 times cos 1 by x is 0, sir.
No, 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 no. I am not asking that step. I am asking from this step to this step. Why I have replaced limit y tends to 0 y at by 0. I'm asking about this step. Not that much big. I'm just asking for better understanding of your continuity part. See, y is a continuous function. Can I say that?
Yes, sir.
Y is a continuous function, and we know that for a continuous function, limit x and or y tending to y naught for any y, it will come out to be y naught. I hope I am correct.
Yes, sir.
So it here y is tending to 0, so it will come out to be 0. So you can, in short, you can say here I am using the continuity of y. Okay.
Yes.
Okay. Now the next part is limit y tending to 0, limit x tending to 0 of the function f x y. So limit y tending to 0, limit x tending to 0, y cos 1 by x. So since that y factor is independent of x, so it will come out, and the left part will be limit x tending to 0 cos 1 by x. Okay. So it will be limit. Can I say that this cos 1 by x limit x tends to 0 exists?
No, sir.
Why?
So because from the sequential definition of limit, we can show that there are two or more sequences which converge to the point 0, but
Hmm.
you put them in the cos function, they will converge to different limits. So that
So tell me such two sequences.
so one is 1 by n pi by 2, and the another one maybe 1 by 4n plus
Can you repeat? One is 1 by
n pi by 2.
n pi by 2. Okay. This will goes to 0.
Yes.
The other one is
So the other one I have to think a bit by it, but I think it will be
hmm.
plus 3 pi or pi by 2. So I have just have to think a bit, sir, this one on this one.
Okay. Take your time and let me know.
So 2n plus 1 pi by 2.
2n plus 1 pi by 2. This will also go to 0. Okay, I am considering these two sequences. Now, can I say that since
Sir, take
x
1 by n pi, sir.
1 by n pi,
Yes, sir.
okay, we will see what we have to take. First of all, I am
Sir, 1
proceeding.
minus 1, the cost, limit of cos n pi does not exist.
Limit of cos n pi does not exist.
Sir, 1 minus 1, 1 minus 1 terms will come.
Okay, I understand. But we can also, I guess, proceed with this. So let me check. So n pi by 2. Since this sequence tends to 0, can I say that this cos 1 by xn will also go to cos 0? Can I say that? Tell me.
Yes, sir. Because
Why?
cos is continuous
Continuous
function.
function. I have wrote this step just to mention you what is the why the continuity is important. So let me go with our basic step. What is cos x by n? Sorry, cos 1 by x by n. So it will come out to be cos n pi by 2. And what is the value of cos n pi by 2? What is the value of? Hmm?
When n is odd, this will be
Yeah,
0.
now you break the sentence. When n is odd, then
0.
it is 0. Okay, that means pi by 2, 3 pi by 2. So any multiple of pi by 2, odd multiple
Yes.
of. Acha, when n is even,
There will be two cases.
two cases. What
One
are they?
multiple of
N is odd, then it will be 0,
minus 1 power n.
minus 1 power n. This will be the best way to say this.
yes, sir.
Okay. Now we have only discarded the existence of this limit with the help of only this sequence. Clearly, this sequence tends to 0, but it's while applying on cos 1 by xn, it is varying. Sometimes it come out 0, sometimes it come out minus 1, sometimes it come out 1. So we can say that limit y tending to 0 cos 1 by y does not exist. And on this behalf, can we say that? We can say that hence limit x tending to 0, limit y tending to 0 cos 1 by y. Oh, I guess I have made some mistake. 1 by x it was some typo. Here I have to take 1 by x, 1 by x into y does not exist. Okay.
Sir, can you show this by epsilon delta definition
See,
that limit of
you
cos
made
n
one thing bad here. Epsilon delta definition is valid only when we know the existence of a limit. Okay. But when we don't know about the existence part, then why? What is the purpose to apply the epsilon delta definition?
sir, by sir negation, sir.
By negation?
Yes, sir.
Um, from my point perspective, this epsilon delta is not a worth to apply here. You may try. Maybe in the next class you can tell me. Then we can discuss it. Okay.
Yes, sir. Okay, sir.
Okay. So here I would like to mention one statement that you also read one result in your class that if the double limit of a function exists, then its iterated limit also exists and equal. But there is a restriction on it. Can anybody let me know? Otherwise, I will write the exact statement. Okay, let me
If
write the exact.
simultaneous limit exists, then the iterated limit will exist and will be equal,
Hmm.
but the converse need not be true.
No, no, no. In this also we need one hypothesis. What is that hypothesis? If that is true, suppose you are saying double limit exists, then the iterated limit also must exist. But here double limit exists, but one of the iterated limit does not exist. So there is no point of becoming them equal. So
Yes,
there
sir.
is one hypothesis that you missed out. That is, let me write it properly. If double limit, that is, we can say xy tending to AB fxy exists, then the iterated limits, and what are the iterated limits? X tending to x naught, limit y tending to y naught, fxy, and limit y tending to y naught, limit x tending to x naught, fxy. These both are equal. This is equal to this, provided that, and what is the condition, or you can say hypothesis, that these and limit x tending to x naught, this fxy, these both exist. Okay. If we know the existence of these two, then we can say that double limit imply the existence of, or imply the equality of iterated limits. Okay. While here, can we say that this above example is contradicting the theorem? Can we say that?
No, sir. Because
Why? Why? Your answer is correct, but
Because
let me know.
it exists, the iterated limit should exist, then only it will
Yes.
apply.
Good. 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 We must only know the first step, that iterated limit exists. Then only we can discuss about the equality of iterated limits by the help of existence of the double limit. Okay. So now let me move to the next question, which is related to your fourth lecture, that is partial derivative. Let fxy equal to x cube minus xy square divided by x square plus y square, and the whenever xy is not equal to 0 0, and the other one is xy equal to 0 0, then find fx at 0 0 and fy at 0 0. Please find this. Or to make it more interesting, what is the addition of this? Sometimes two times, you can see that. What is the addition? Please tell me. Let's start doing parallel. How we can compute fx at 0 0?
Limit h tends to 0,
Yes,
f of 0 plus h,
yes,
comma 0,
okay,
minus f of 0 0
yes,
whole divided by h.
correct. Now put this in this function. So it will be come out to limit h tends to 0, 0 plus h cube minus 0 plus h into 0 square divided by 0 plus h square, 0 square, minus, what is f 0 0? It is 0, divided by h, limit h tending to 0, h cube divided by h square and whole divided by h. So it is come out to be 1. I hope everybody is okay with these steps. If yes, then can we go to Fy00? Okay. What is Fy00? So it will be limit k tending to 0, 0, 0 plus k minus F00 divided by k. I hope everybody is convinced with this definition. Shall I go further? Okay. Limit k tending to 0. So it will come out to be, what is the function? X cube minus xy square. So 0 cube minus xy square yani 0 plus k square, 0 square plus 0 plus k square minus 0 divided by k. What it will be? What is the value of this? Tell me. What will be the value of this?
0.
0. And what we have to find out? 2 times of fx at 0, 0 and 3 times of fy at 0, 0. 2 times of fx at 0, 0 plus 3 times of fy at 0, 0. It will be 2 into 1 plus 3 into 0. It will come out to be 2. Anybody have any doubt in this? Shall I move to the next question?
Yes.
Okay. The question number 7. Find the slope of fxy is equal to x cube y plus x square y square in the x direction as well as y direction at point 2 comma 1. We have to find out the slope of the function fxy in the x direction as well as in the y direction at the point 2 comma 1. So can anybody let me know what is the meaning of this question? What we have to find out?
So partial derivatives with respect to x and y.
Okay. Everybody is convinced with this argument, this answer? In the lecture number 4, it has been told you that slope, while we have talking about the two variable function, that the slope in the x direction means partial derivative with respect to x or y?
X.
X. While in the y direction, we have to find out the partial derivative with respect to y. So you have to do nothing, but you have to find out fx1 2, sorry, 2 comma 1, and you have to find out fy 2 comma 1. These two values you need to find out. So find out and let me know what is these two values.
So is it 16?
16 both.
Both?
Both.
Okay. Let us see. Fx 2 comma 1. So Again, we first write the definition. What will be the definition now? F, tell me, 2 plus h, comma 1 minus f 2 comma 1 divided by h. I hope the definition is correct. Limit h tending to 0, 2 plus h cube into 1 plus 2 plus h square into 1 square divide by, sorry, first of all I should write minus divide by h. So what is the value of f21? F21 will be 8 into 1 plus 4 into 1, 12, right? Anybody? Samadhi?
I have done this problem in a bit different method. I have simply just done the partial derivative of the functions with respect to x and y and put the value.
Okay. Okay, I will do with that also. Let me do first in this
Yes,
way.
sir, it will be 12.
Okay. So it will come
WhatsApp
out to be,
as it was
yes.
did that.
Your voice is a little breaking, Samadhi.
Sorry, sir. Actually, as the function was not breaking anywhere, like the previous one, 0, comma 0.
Yeah,
So
I
I just
understood.
partial
Yeah,
derivative.
your method is correct. I will let you let the other people also by that method. First of all, let me do with this. So it will come out to be h cube plus what will be 3 times 2 square, that is 2 to the 4, 12 h, and the other one is 3 to the 6, 6h square plus, and here the 12 will cancel out with the both, and the other in h square plus 4h divided by h. So it will come out to be limit h tending to 0, h square plus 12 plus 6h plus h plus 4. So it will come out to be 16. I hope everybody is convinced with this approach and this answer.
Yes, sir.
Okay. Now the other method can be possible. We can directly calculate the partial derivative. So how can we calculate directly the partial derivative? So it will be del x of fxy. So del by del x of what is the function x cube y plus x square y square. Now we need to differentiate with respect to x, and keeping in mind that other independent variables are constant. So if we will do that, y will be treated as constant and it will be x cube plus, and y square is also constant, and in differentiation we can break over the addition. So it will be come out to be 3x to the power 3 minus 1, and here 2x to the power 2 minus 1. So it will come out to be 3x square y plus 2x y square. Okay. In this way you have done, I guess, Swamiti.
Yes, sir.
Okay. Now you can put f here 2 1. So 3 2 square into 1 plus 2 into 2 into 1 square. So it will be come out to be 12 plus 4. It will be 16. Okay. In the similar way, we can find out f y x y. So the change will be only the thing that now we have to differentiate with respect to y, keeping x as constant. So if we do that, it will come out to be x cube del over del y of y plus x square del over del y of y square. So it will come out to be x cube plus 2x square y, and fx fy at 2 comma 1 will be 2 cube plus 2 into 2 square into 1. It will come out to be 8 plus 8 again. That is again the answer is 16. Okay. If everybody convinced with these answers, can we move to the next question? Okay, let me move to the next question. Find out the domain and the range of fxy, which is equal to ln y minus x. Find out this domain and the range of this function.
Sir, y minus x should be positive and range is close 0 to infinity.
Closed 0 to infinity. Any other
Set,
answer?
set of all x comma y in R2 such that y greater than x.
Okay, and what will be the range?
The range is square bracket 0 comma infinity.
Okay.
Hmm?
Any other answers?
Range.
What? Your
I
voice
mean,
is breaking.
I mean,
Amit.
Sir, 0 is not included.
0 is not included.
Yes, sir.
Okay. Earlier, one person is saying, I guess 0 is included, right? Okay. So, how can we decide the domain and the range of the function? First of all, let me recall that from the lecture 1. How can we define the domain and range of a function? Tell me, anybody? Everybody, I guess, attending the lecture 1. What is the domain of any range of a function? Let me write here. Domain
mind
of f is equal to the collection of,
properly.
Samadi, your voice is breaking. Such that fxy is defined. Now tell me when log ln function, you can say, is defined. When it is well defined, ln x, or you can say ln z, is defined
When z is positive.
if z is positive, or you can say when z is positive. Okay. So here what we have to take, that y minus x should be strictly greater than 0. So what will be the domain of f? Domain of
Sir, 0, sir, should be included in the range. Range of
0 should be included in the range.
yes, sir.
Okay, let's see. xy such that y minus x is strictly greater than 0 and y strictly greater than x. Okay, this is the domain of f. Now let us discuss what is the range of f. It is range of f. It is collection of all those real numbers z such that z is equal to fxy for all xy belongs to the domain of f. Okay. So for this, from this behalf,
Hello, sir.
we yes please.
So, I think the range of would be full line.
Somadeep, I guess your voice is breaking. Could you repeat it? What you were saying? So let me proceed further. Since range of f is kind of ln function,
I think the
so
entire real line.
entire real line, the answer would be. Why do you think so? Entire real line. Earlier, someone is talking about like, I mean, 0 to infinity.
Rho 0.
Now, someone is saying close 0 to infinity. Acha, tell me, what is the graph of ln x? We can discuss it out here. Suppose we have some function f of z ln z, and z is here any real number. What would be the graph of this?
Intersect
What?
and then we'll take one at E continues.
Um, somebody, your voice is breaking. I don't know why. Any other?
Or when z tends to 0, ln z tends to minus infinity,
Okay,
and at 1 it is 0,
okay.
and when z tends to infinity, ln z tends to infinity.
So to draw any graph, I would like to just recall some basics. That first of all, we find out derivative. F dash z will be 1 by z. So whether it will be a increasing function or decreasing function, anybody?
Increasing.
Increasing, always.
Yes. When sir base is
Hmm.
positive. Oh, sorry, base is greater than 1.
See, with the help of derivative, let me know when the function is positive. With the help of derivative, we can say that when the function is negative. Let me know that.
F double dash z, if second derivative is negative, then
Good.
it is increasing.
F double dash z will be come out to be minus 1 by z square. So this minus 1 by z square is a always a non-negative quantity, right?
Sorry, sir. First derivative positive, then it is increasing, and if
Now you are getting it.
for
That
maximum and
this
minima we
double
calculate
derivative
second
is
derivative.
valid for this double derivative is valid for only
Maximum we when we calculate maximum.
to check the maximum and minimum value, and the
Yes,
other
sir.
thing is the concavity to decide the concavity of a function.
Yes, sir. Yes.
Okay, this single derivative will let you know whether the function is increasing or the function is decreasing. So here, what will be the critical point? Critical point will be 0. Okay, critical point will be 0 now.
Yes, sir. F dash z
And
is not
one
defined
more
at
thing
0.
I would like to mention here. What is the domain of this function f? I would write here to avoid the confusion the function h so that you cannot confuse with above example. Domain of this h will be
Positive real numbers.
positive real numbers, yani 0 to infinity, right? So positive real numbers, it is obviously clear. This single derivative will be strictly greater than 0.
Greater than 0. Yes, sir.
I hope I'm clear with everybody. It is clear. So it is an increasing function. And now you know that at 1, ln1 is 0. And somebody told that it is minus infinity at when x tending to 0. So if you will draw this graph, wait, just a second, let me draw it. Since it is an increasing function, so it will go to this minus infinity, and here it is 1 comma 0. So how many values of this h is covering? Tell me. Here, tell me the range of this h with this help of this graph. Tell me what is the range of this h?
Whole R.
Whole R. So
Yes, sir.
somebody is telling me that range of the above function would be 0 to infinity
Yes,
or
sir. It
rho
was
0 to
me,
infinity.
sir.
I hope it is clear now.
Yes, sir.
Range of h will be whole R. Okay. But we have here talk about only single variable. But what is our function? Our function fxy was ln y minus x. This is a function of some two variables. So we can what we can say that range of this f will be subset of range of ln z, some ln z, and which is equal to real number. Okay. Since it's a type of real function, we can say that it is a subset of real number. Now we just need to show that real number is also a subset of this. If you want to show that a is equal to b, what you will do to show
A
this
is
a equal
subset
to
of B
b?
and B is subset of A.
Good. We need to show that a is a, let me check, a is a subset of b and b is a subset of a. So for to show that the other part, we consider take x is equal to 0. Then f 0 comma y will be ln y. Now what is the range of it is ln? Tell me. Ln y is polar,
Whole R. Yes.
polar. And we have fixed 1x. So that means when we have fixed 1x, we have whole r in the range of f0y, or you can say fxy. So that means r can also be said to be the subset of range of this f. So this is one inequality and this is another containment, sorry, inequality. Range of f will come out to be exactly r. I hope now it is clear to everybody that it is whole r and it is not 0 to infinity and not this open loop. Okay, this is whole r. So I'm just erasing this. Now let us move to the next question, which will let you know the another way of seeing the continuity. So the question number 9 is let
Sir, you have not discussed continuity yet.
what what have not discussed.
Sir, you have not discussed continuity of a function of several variables.
Oh, I have
You have
discussed in one question. Can I remind it? Let me know. Wait. Here, this question number 5. In this question number 5, I mentioned here that here they are talking about the continuity. Okay.
okay, sir.
They
Okay, sir. Okay. Yes, sir.
Yes. I will also give you one more example to guess the what is the continuity, how to get it. Okay.
Yes.
So here, let me move to another approach of continuity, or well, rather, let me tell you first. Let me discuss with you how to check the continuity. Now, check the continuity of fxy, where a part fxy is defined x y cube divided by x square plus y to the power 6 whenever xy is not equal to 0, 0, and the other part is whenever xy equal to 0, 0. Check for this. And the another one is fxy xy square divided by y square whenever xy is not equal to 0, 0, and 0 whenever xy equal to 0. Could you please mute yourself? Muthu Kumar ji, please mute yourself. Thank you. So with these two examples, illustration, we can see, understand how the continuity, how to check the continuity of a function. So can anybody let me know the formal definition of a continuity? How to check a function is continuous at some point? Suppose I am telling you function f is continuous at some point AB. Then obviously we are talking working in two variables, so function is r squared to r. So can anybody let me know what is the formal definition of continuity? What we have to see to check the function is continuous?
For any epsilon positive.
No. Wait. That is a formal definition. You are directly going to that. First of all, we need to check this f of AB is defined or not. First of all, it should be defined. Okay. F is continuous if second condition that you were talking about, that limit xy tending to AB, this fxy exists. Okay. And the third one, the last step, that limit
X should be
xy.
equal to f of AB.
Good. I hope now you understand. You were doing some directly calculation that you are assuming it is continuous. That epsilon data definition comes into act when we know that it is already continuous at AB. Then we can show that. Here we need to check it is continuous or not. So now tell me, we have to check the continuity at 0, 0. So tell me, can anybody tell me here why I am saying we have to check the continuity at 0, 0? Why not other points? Please let me know.
Because it is a polynomial.
If we go through the path along x equal to my cube,
Wait. Please understand, Swamadip. I am first talking about why I am talking, why I am only saying we have to check the continuity at 0, 0. First, answer that. Then we go to that your step you were saying.
But because polynomials are continuous everywhere.
Huh. So whenever xy is not 0, 0, we have a function xy cube divided by x square plus y to the power 6. Both the functions are continuous, and we know that by algebra of continuous function, if f and g are continuous and the denominator is not equal to 0, then we can say that f by g also continuous. Let me mention here, if f and g are continuous function with gxy is not equal to 0 for all xy, then we can say that f by g is also continuous. And here, being a polynomial, x cube y is also continuous. Xy cube is also continuous, and x square y plus y to the power 6 is also continuous. So that means xy cube divided by x square plus y to the power 6 is continuous for all xy not equal to 0, 0. So we can guarantee till when xy not equal to 0, 0. But what if xy equal to 0, 0? So for that we need to check. Now we can proceed with our continuity statement. We know that f of 0, 0 is equal to 0. I hope everybody can see this.
Yes, sir.
Okay. Now the next step, what is the existence of limit? Now somebody, you can give your argument. The limit exists or not? Whether.
No, so the limit does not exist.
Why?
If we go along the path x equal
Hmm.
to m cube, then we can see that the value of this limit, I mean the value function of this limit
Okay.
will be
Let me explain it more clearly. Earlier we have talked about the path y equal to mx. Here we are taking x equal to my cube. Why? This is the reason why I have given this type of example here, because we should
mathematical.
understand what Samadhi.
No, sir, I was telling that I have chosen this path for my
Mhm.
mathematical and to show that this depends on m.
Yeah,
But
but there is some reason now. Earlier we have taking y equal to mx. Here we are taking y equal to sorry x equal to my cube. So this is why our function is fxy is x y cube divided by x square y to the power 6. What is the highest power of denominator? In this
6.
with 6. Okay, our target is to take out common 6. Okay, we have to choose such curves to check the limit existence. So here it is x square and here it is 6. So what can be the value of x in terms of y so that its power also becomes 6? Tell me.
Y cube.
Y cube. And since we are taking generalized curve, so we have taken x equal to my cube. I hope am clear with this curve chosen, x equal to my cube.
Yes, sir.
Okay, good. Then limit xy tending to 0, 0 fxy, it will come out to be limit x tending to 0. As x tends to 0, sorry, it will, as y tends to 0, then x also tends to 0. That's why I have only consider y tends to 0. So put this value in this, m y cube into y cube divided by m y cube plus y to the power 6. I have made a mistake here, typo. Now tell me, what will be the output of this? M y to the power 6, y to the power 6, m square plus 1. And it will come out to be m by
1
m,
plus m.
and it is dependent on
M.
m. So whenever it is dependent on m, then limit can exist?
No, sir.
No.
Because for different values are m, we will
Ha,
get different limit.
exactly. So does not exist. Okay. So if it is not existing, then we have stopped to the step 2 of definition of a continuous function at a point. So this function is, I'm sorry, limit I should not write here. This function is not continuous at 0, 0. I hope I am clear with this. Okay. Now what is the second function? Second function is xy square divided by x square plus y square. I am not writing it properly. I'm just letting you know. First of all, first we have what we have to check, FAB is defined or not. So see here, whether FAB is defined, that means F00 is defined.
0.
Okay, okay. Um, so I will give one more argument here. We are only checking the continuity at 0, 0. Otherwise, except 0, 0, the function is already continuous with the same argument given in the part A. Now we are checking the continuity at 0, 0, and as told by Meera Tiwari ji, that F00 is 0 already. Now we just need to check first of all the limit of existence, and then we can check that limit existence is equal to f of 0 0 or not. So now let us check the existence of a limit xy tending to 0 0 fxy, limit xy tending to 0 0. What is the function? Xy square divided by x square plus y square. Xy square, x square plus y square.
Sir,
Yes, please.
sir, I am Sir Sandeep Tiwari, sir.
Okay, I'm sorry. It has been showing, I don't know why, Meera Tiwari. Sorry for that.
Sir,
So,
because sir, my mic is not working in laptop. That's
okay,
why yes, sir.
okay. So here we need to check whether this is what is the existence of limit. So here I would let you know the polar coordinate approach. Why? Because it is becoming here 0 by 0 form. So you cannot tell directly. So we will take the help of polar coordinate. So what is in case of polar coordinate happen? Corresponding to xy tending to 0 0, we get limit r tend to 0. I have already told in the above slides also, and you might check lecture 1, I guess. Lecture 1 is, no, I guess lecture 2 or 3. So it will be r cos theta, r sin theta square divided by r cos theta square, r sin theta square. And r square will be x square plus y square. So whenever xy tending to 0 0, that means r will tend to 0. So limit r tending to 0, it will come out to be r cos theta sine square theta. I am skipping one or two steps. It will come out to be directly this. I hope everybody is clear with these steps, how it is coming out. Shall I proceed?
Yes, sir.
Huh.
Sir,
So,
this 0 by 0 form, how you are saying this 0 by 0 form?
okay. See here, xy is tending to 0 0. When xy is tending to 0, numerator goes to 0.
Sir, in our real examples, there were also these forms, sir. 0 by
That's
0 form.
true. But earlier examples, we need to show the existence of the limit. At least we should know now what is the limit here. So to get the understanding of limit, we have to go for the polar coordinate approach, so that by simplicity we can judge what is the limit of this. Okay.
Sir, we don't know what is the limit of this
So
function.
that
Yes.
means there you also have to check with the help of a polar approach or something, some other approach, that what is the value of the limit. Then only you can show that epsilon by delta definition.
Sir, if
Okay.
limit does not exist, then
Then obviously, then if the limit does not exist, then we have to take a curve to different paths, y equal to mx or some y equal to mx square. Okay.
yes, sir. Okay.
Okay. So here r tends to 0, and while these values are finite values between -1 to 1, so it will go to 0. Okay. Second condition is also satisfied. Now, what is the value of f00? It is 0.
Yes, sir.
So that means we have shown that limit xy tending to 0 0 fxy exists, f0 is defined, and it is equal to f of 0 0. Hence, f is continuous at 0 0. I
Sir,
hope. Yes, please.
sir, when we consider x is equal to r cos theta, y is equal to r sin theta, so basically we are considering circle.
Yes, you are right.
So my question is, it covers all the curves on the plane, sir, by
Yes,
taking
yes.
how, sir? How?
See, you are drawing circle around this 0 0, right?
Hmm.
And in epsilon delta definition also you consider that circle, that 0 is less than under root x minus a square plus y minus b square less than delta. Okay.
Hmm. Yes, sir.
We have considered here this curve, and we are just guessing what can be the limit of the function. Here we are not saying it is covering. it might be also possible ki here also we are not getting any value of limit. I have shown in the earlier example also. Let me mention from there, then you will get the better understanding. See here. Here we have taken x r cos theta by r sin theta. And what we are getting an expression dependent on theta,
Yes,
right?
sir.
And then depending as theta changes, then what will be the limit? Limit will change, right?
Yes, sir.
And limit will change. That means a limit does not exist. And
Yes, sir.
here in the current example, luckily we got the zero and that is equal to f of 0, 0. Then only we are able to guarantee the continuity. Okay.
Sir, sir, my question is how this
Uh,
circle covers all these curves. If we
See,
are, yes, sir.
I am not saying that these are covering all the curves. I am just taking here help the polar coordinates just to show that will be the existence of the limit. Okay. Clearly, it is independent of R. I can, with the help of these steps, I can only here guarantee about the existence of a limit. Okay. How it is covering the limit that for the time being, I am I'm sure I'm not
Sir,
sure.
then we have to sir prove, na sir.
What?
Sir, then we have to sir prove that limit is
Um,
zero.
See, this is the well-defined method, I guess, in lecture also, which has been told by sir. So let me give one more bit time. I will let you know how this is covering all the curves. Maybe in the next class, I will let you know.
Yes, sir.
Okay.
Okay, sir.
For the time being, I can say one thing that you are taking x equal to r cos theta and y equal to r sin theta, and you are drawing the circle, and theta is varying.
So
Yeah, I got
R
the,
is
I
R
guess
is
wait, please. Then let me complete.
R
Uh,
is not fixed.
yeah,
If
exactly. That's what I'm telling you. Just wait, please.
if R is equal to A, then only you can talk of inside the circle and all those things. R
Exactly,
can be
exactly.
take any value.
R is not fixed, and also theta is varying. Okay, so it is covering all the covers. Theta is this angle, na?
It's
And this
covering
is
all
radius
the sir
r.
plane.
Yeah, all over the plane. Dekho. See, what is this is radius r,
Yes, sir.
right? And this is angle theta.
Yes, sir. Yes,
So
sir.
r is not fixed, as told by one of the student, and theta is also not fixed. These are varying, no? So
Yes, sir.
drawing these circles will cover all the curves. Okay.
Sir, if we take parabola as a parametric equation, then will it cover the plane?
Parabola.
Yes, sir.
I don't think so because it is not a closed figure. You have to cover whole the r square. Huh? It is covering the r square that I have let you know. But what parabola with the help of parabola you cannot cover. I think.
Yes, sir. Okay.
Okay. So I hope this continuity part is clear now. Now let me go to some other question. The next question, which is let fxy equal to sin x plus y square, then okay, if alpha into fx 0 comma 3. By the way, that was a good question, how this polar coordinates is covering all of the curves, plus
Yes, sir.
beta fy 03 is equal to f03. Then then alpha is equal to what value? Please solve it and let me know what is the value of alpha here. We might go with the approach basic definition of partial derivative or we can also go with directly partial differentiation. Then we can put the value of these points.
So 3.
3. Okay. Any other answers? What is the partial derivative? Fx of this del over del x
Cos.
of sin x plus y square by the algebra of differentiation. It will come out to be this, and
Cos.
differentiation of this is cos x, and it will be treated as constant
0.
0. It will come out to be cos x, and fx at 0 comma 3 it will be 1. Okay. Now let us move to the derivative with respect to partial derivative with respect to y. It will be sin x plus y square. So it will come out to be del over
2y.
del y sin x del over del y square. So it will be 0 as we are treating x as constant and differentiating with respect to y. Partially differentiating with respect to y. It will come out to be 2y. And fy at 0 comma 3 will be 6. Okay. And what is the value of f 0 comma 3?
9.
9. So we have the equation alpha times 0 comma 3 plus fy 0 comma 3 is equal to f 0 comma 3. Okay. So it will be alpha times 1 plus 6 equal to 9. Alpha is equal to 9 minus 6, which is equal to 3. I hope everybody is convinced with this answer, alpha equal to 3. So let me mention one more question for your continuity understanding. I mean continuity of a two variable function, e to the power x tan inverse y divided by y, where xy is not equal to 0 0, and whenever xy is equal to 0 0, let me change here, this is some k. So now what is the value of k if f is continuous at 0 0? Tell me, what is the value of this k if I am telling you that f is continuous at 0 0? Anybody? First of all, what is the continuity at 0 0 will imply?
Try with k
Function
equal to
value
0.
and limit should be equal, sir.
Can you repeat it? You saying right?
Sir, at 0 0, limit of f and
Mhm.
value of f should be equal.
Good. So continuity at 0 0 means this limiting value at 0 0, and the value of function at 0 0 will be equal. So, and we know that this f of 0 0 is k. So what is the rest part? We need to calculate what is the limiting value of this fxy. I hope I am clear.
Yes, sir.
So what is the value of limiting value of this fxy at 0, 0? So limit xy tending to 0, 0 e to the power x tan inverse y by y. Limit xy tending to 0, 0 e to the power x. Limit xy tending to 0, 0. Is there any Somadeep, you are
One.
not audible.
Hello.
Yes.
Is it equal to 1 value of
Mm,
k?
yes. So can anybody let me know how I'm coming this step to this step? Like why I'm able to break these limits.
Sir,
I
because
have
limit exists because this e to power x and limit of tan
good,
inverse y
good.
1 by.
So if formally I say if f and g are continuous, that will imply f into g is also continuous. Okay. So it will come out to be e to the power 0. Why? Because e to the power x is a, tell me,
Continuous.
continuous function.
Continuous function.
And the other part is, what is the value of limiting value of tan inverse y by y?
1.
1. And what argument can you give on this behalf?
Sir, by expansion of tan inverse y.
Okay, that is a good answer. And there can be one more approach. What can be that?
Sequential approach, sir.
Sequential approach. So what can we take in the form of sequence?
Tan 1 by 1.
Let me know one more approach. You can
Can you
check
apply
it.
this L hospital rule also?
Yes, separately we can
Three
apply
before
the
one.
L'Hopital rule also, but I am telling you the real analysis approach of squeeze theorem. So
Okay, sir.
squeeze theorem says that this tan inverse y will lie between these two functions. You may check that. Okay. So with the help of this, you can tell that limiting value of tan inverse y will be limiting value of this function limit y tending to 0 of 1. So what will be the
Sir, how
output?
you are getting these inequalities at this?
Okay,
Such as yes, sir.
yes, I understand your question, but you need to check it once. Like you know that sine theta is less than equal to theta and less than equal to that tan theta. So you might go with that and replace theta with tan inverse x. Then you will get to this, and you have to solve sine tan inverse x is equal to, and this
Yes,
sine
sir.
tan
Yes.
inverse x will come out to be y by 1 plus y square. Okay, I hope
Yes.
I'm clear now. So here, so what is the value of this here? This will be 1 less than equal to limiting value of tan inverse y by y and less than equal to 1. Okay, so it will be come out to be limit y tending to 0 tan inverse y by y equal to 1. Okay, so with
Yes,
the
sir.
help of this, here we can say that this is 1. That means this is the value of k. So k will be equal to 1.
1.
Okay, now let me conclude with the last question. Let let fxy is equal to xy into x square minus y square divided by x square plus y square, where xy is not equal to 0, 0 and 0 when xy equal to 0, 0. Now examine the continuity of f. This is the last question for today class. Please let me know what is the continuity of this function. First of all, let me know whether the function is continuous for any points rather than 0, 0. Can we say that the function is continuous?
Yes, sir.
Why? I have given an argument on our question also.
By algebra, sir.
By
Continuous.
algebra of continuity, we can say that this function is continuous for all the points xy which are not 0, 0. Now, what if xy is 0, 0? We have to check that. So for that, we need to calculate we know that f00
Sir,
is defined.
here, sir, we can take, sir, polar coordinates, sir.
Okay, I will do with that. Here, first of all, you can see that f00 is defined.
Yes,
I
sir.
hope everybody is clear with that. Okay. The second step is to calculate the limiting value. Limiting value xy tending to 0, 0 fxy. As someone suggests the polar coordinate, so we will go with the polar coordinate approach. So it will come out to be r square cos theta sin theta. And in the above expression, r square cos square theta minus r square sin square theta, and divide by r square cos square theta plus r square sin square theta. I hope everybody is clear with these steps. Then limit r tending to 0, 0 r square cos theta sin theta, and this will be cos square theta minus sin square theta. I hope this is will be the only expression left with be with us.
Yes, sir.
Okay. So since these all are finite values between -1 to 1, I mean each of the finite values, then after the multiplication, it can be some finite value. So and r is tending to 0, 0 or r is tending to 0, then what will be the limit?
0.
0. And what is the value of f00?
0.
So that means hence f is continuous on whole r square. Okay.
Sir, why do we need the finiteness of cos theta, sin theta, cos square theta minus sin square?
See,
Because theta
आपको
is not varying here.
see theta we have taken s equal to r cos theta and y equal to r sin theta. For in these polar coordinates, what is the value of theta? Tell me. For these polar coordinates, theta lie between what? 0 to 2 pi, na?
Yes, sir.
So that's why I'm saying, na? And finiteness is needed. Suppose there is expression 0 into infinity. Can you tell me what is the value of 0 into infinity?
Define form.
Not defined, undefined form, na? So to
Sir,
make it, yes, please.
but my question is here that r is tending to 0, sir. We are only considering r, sir, limit of r.
Yes.
Whatever the sir terms are, if they are
Theta
written,
is also varying. That doesn't mean theta is not varying. But why I am considering r? Because see, x square plus y square equal to r square. True.
yes, sir.
Yes.
And when xy tending to xy approaches to 0, with the help of that, what can you tell?
R tends to 0.
R tends to 0. That's why we are taking limit here r tends to 0. But that doesn't mean that theta is not varying. Theta is also varying between 0 to 2 pi. Okay. Theta is varying. As I told you in the above example, in one of the examples, that when it is coming out not zero, some value depending on theta, then we can say that limit does not exist, because as theta varies, then the limiting value will be varying. Okay.
Yes, sir. Yes.
I hope now I am clear with all the questions.
If it comes independent of R, sir, the
Ha.
expression,
Dependent on
then
theta, you can say that. Dependent on theta.
dependent on theta, yes, sir.
Yes. Then we can say that it is the limit does not exist.
Yes,
Okay.
sir. Yes, sir.
I hope all the questions are concluded now.
Yes, sir.
So let's today end the session. Okay.
Yes, sir.
Okay.
Second,
Bye. Yes, please, Somadi.
can we get the sir?
Sorry, Somadi, you are not audible. Somadi, you are muted. Please unmute yourself. Yeah, I guess Somadi, you will get the PDF. Okay.
Sir, for this course, you are the
Hello,
only TA.
Someone is saying, please.
Yes.
sir. Can we get this video also?
I guess so. Yes, you also get the video.
O- Okay, sir. Okay. Thank you, sir.
Yes, I guess someone
If,
else was asking something.
sir,
Tiwari ji?
you are the only TA, sir, for this course, because
Um,
other courses have two TAs.
I guess this is a 8 week course, so I'm also only 130.
Yeah, yeah, okay. Sir, can we get your sir, mail?
Uh, I guess it will be shown in the that course details maybe.
Sir, please type here, sir.
Okay,
Okay, sir,
I
please. Chat
okay.
box.
I'm not sure whether I'm allowed to do that or not. So I will share my video and my slides with you. Maybe in the next class I will let you know if I can share that also.
Yes, okay, sir.
Okay. Okay.
Okay, sir.
Bye.
Thank you.
Thank you.
Sir, the next